Dear Manu, dear colleagues, I'm happy to share with you my pictures of future flooding. Let's look at the flood situation today. Globally, 1.8 billion people are exposed to flooding. Here you see a number of flood disasters from the last 3 months, taken from the flood list homepage, which reports about flooding all over the world. So we are literally flooded by news about flooding. Now let's look at some of the challenges of today in a bit more detail. Here you see the number of disasters due to natural hazards broken down into different hazard types. Two observations are important for us today. Firstly, flooding is responsible for the largest share of disasters due to natural hazards. And secondly, the number of flood disasters has been strongly increasing over the last decades. You see that when you compare the top row showing the number for the 80s and 90s with the bottom row showing the number for the last 2 decades. Another interesting observation is shown here. Here you see the observed number of daily rainfall records aggregated over the landmass. So many thousands of climate stations aggregated over the landmass for a certain year and shown as time series. And this observation is now compared to the number of records that you would expect in a stationary climate. And this is shown by the x-axis and by the uncertainty interval, the blue interval. And what is interesting and worrisome is that the observed number of records has left this uncertainty interval, what we would expect in a stationary world in the 90s. Now, we know that has been shown by a recent study by Kreibich et al. That societies learn from droughts, from floods, from extreme events, but they are very much focused when they learn on the specific event, and they have a hard time to learn for events that are different or maybe even more severe. And finally, I would like to point to the fact that poor people, disadvantaged groups, are hit harder by extremes. They tend to recover more slowly and suffer more from long-term consequences of disasters. So overall, a quite gloomy picture if we look at flooding today. But as your institute is about global water futures, now I look into the future and I will share with you what I have seen when looking into the year 2050. Now flooding in 2050. Here you see the fake list flood news from March 22nd, 2050. And what do we see here? Good news, only good news. For example, despite an unprecedented rainfall, all communities that were hit by this flood are found safe and well. The UN Disaster Risk Reduction Office has announced today that every person globally has appropriate safety against flood hazard. Flood-related fatalities are down to an all-time low. So good news everywhere. Now, you may wonder, how have we, so we meaning scientists, citizens, governments at all levels, non-governmental organizations and so forth, how have we managed to achieve that? Well, I can't tell the whole story, it would take too long time, but I will share a few bits from this story. Now in 2050, scientists do understand the key factors that turn extreme events into disasters. Let's first look back in the early 2020s. Here you see the flood peak time series of the River R in Germany in the year up to the year 2020. At that time, we had systematic measurements of more than 7 decades, but still it was hard to conceive that we would have the flood in July 21. This flood was 5 times higher than the flood of records in more than 7 decades. So this is very hard to extrapolate if you use statistics. So, but what we learned in the early 2020s is that we need to understand the processes. Here, for example, you see the same data, but now ordered over the year. So the blue dots are the systematic measurements, and then we added 5 historical floods in this river valley that had been reconstructed earlier. And what do you see here? Most of the floods occur in winter, and they are typically not larger than 200 cubic meters per second. But it can occur that we have an extreme flood, an extraordinary flood in the summer, which is much, much larger. And the point is that we have different processes, different precipitation events, different interaction between precipitation and runoff generation. And we need to understand these processes in order to extrapolate. And we had learned that in the early 2020s. We understood that extreme events are not necessarily the large version of the frequent events that we can observe. So today, flood estimation, flood design and management are based on process understanding. We have identified the causes of heavy tails of our flood peak distributions. We extrapolate to rare events, but we include causal links, processes. And this causal understanding even extends now to the impact to the socioeconomic processes. We now understand what makes society vulnerable and reduces their resilience. We even have models that include human behavior. Today in 2050, society is prepared for unprecedented events. Let's again look back to the early 2020s. At that time, we had a hard time to think about and prepare for real extreme events. One of the reasons was the cognitive biases that we all have. So we attach a too small probability to events that we have not seen, not experienced. We also perceive adverse events as less likely for ourselves than for others. Yes, our neighbor is at risk of flooding, but me, I'm not. In the early 2020s, together with psychologists, we came up with new approaches to communicate this kind of extreme events. Up to that time, we spoke about the 100-year flood, the 1,000-year flood, but lay people could simply not really understand what this concept meant. Policymakers said, well, I have a mandate for 5 years. Why should I care about the 1,000-year flood? Now, one of the new approaches we developed are counterfactuals, spatial counterfactuals. So we took a real event and said, what if this storm track would have taken a slightly other path? And you see this analysis here again for the July 2021 flood. You see the path of the low pressure system Bernd. And in the middle, you see the hydrological severity of this event as it was observed. So red means catchments with catastrophic that have been hit catastrophically, and blue means catchments that have been hit moderate to hard. And now look at the right map, and this shows the same event, but just shifting the storm track 50 kilometers to the northeast. And if this would have happened, the situation would have been much more severe, and cities that have been spared from havoc in the real event would have been flooded. And now we take this kind of events and say, well, last month there was this event. You have managed it well, you think, but maybe it was just sheer luck. Look, if the storm track would have taken another path, then your city would have been flooded. And then this is easy to understand for everybody. And then we sit down with emergency managers, with citizens, with policymakers, with spatial planners, and discuss what could be done in such situations when our structural flood defenses are overwhelmed. How can we minimize losses? Then we look at, for example, sensitive infrastructure, the kindergarten, the care home for the elderlies. We'll look at critical infrastructure. How can we safeguard that mobile communication is still functioning? Things like that. And in that way, today in 2050, we are not now much better prepared for unprecedented events and things that can come kind of out of the blue. So today in 2050, the local emergency teams use the latest technology to optimize their emergency actions. Let's look again back to the early 2020s. Here you see again the Aar River Valley and the flood in July 21. At that time, 135 people died, although the precipitation forecast was pretty good and several days in advance. And also the stream flow forecast was not too bad. But the local emergency teams, they just couldn't well translate this information into their actions. This situation has completely changed today in 2050. The stream flow gauge based forecast of the old time are now extended to spatially distributed forecasts. We have forecasts on a building level. So we say in 12 hours, this building will be flooded by 1 meter. Our forecasts do not only include flood variables, but also impact variables, as shown here in the lower map. So we forecast the locations where people can't stand due to high water depth or high water well losses. We forecast the roads that are blocked, that are flooded due to the event. Our local emergency managers have access to a multitude of near real-time data from drones, from satellites, and other sources. And today they have a very good picture about the current situation. Those local teams use fast models, and these models can be implemented on the fly to explore in advance different emergency options. And maybe the most important advantage is that we have early warnings with recommendations that are tailored to the local situation, to the local people, the local audience. So there are very clear recommendations like, now don't go into the basement to try to save your washing machine. Get out of the house within 1 hour and get to location X. And by the integration of this latest technology, we have managed to bring fatalities and damages tremendously down. Today in 2050, society understands and manages systemic risks. Flooding is embedded in a complex web of processes, natural processes, societal processes. These processes change over time and are interconnected with each other. In the early 2020s, we still were kind of tinkering around and trying to address problems in a singular way. But Today in 2050, we have a completely different approach. We have overcome the thinking in silos and have replaced it by a system thinking. So what does it mean? For example, water management is now organized across sectors and problems. So for example, droughts and floods are assessed and managed jointly. Engineers, natural and social scientists now today develop models of systemic risk. They include the societal processes, they include human behavior. And our models are developed in close cooperation with decision makers and affected people. So to understand their concerns, their demands, but also to exploit their local knowledge and to better inform our models. Looking back over the last 25 years, I think this development was the most important achievement that we made. So going from this kind of fragmented approach to an overall systems-based approach. So with these pictures from 2050, I wish you all the best for your new Global Water Institute. I would have liked to attend in person at your launch event, but this time it was not possible. I promise I will come in 2050 to jointly celebrate with you your achievements in solving global water security issues. Thanks a lot. All the best.